Today I'm going to discuss on the topic ion channels. Myself, I am Dr. Devagnand, working as Assistant Professor in the Department of Physics, Sri Narayana College for Women, Kollam. So what are ion channels? Ion channels are membrane proteins which selectively gates ions across the membrane. There are a variety of them classified based on the stimuli they are sensitive to. For example, there are voltage gated channels, there are ligand gated channels, or there could be pH gated channels, etc. etc. Variety of them. They can also be classified based on the ions that they conduct. For example, if the ion channel conducts sodium ions across the membrane, they are called sodium channels. If they conduct potassium channels across the potassium ions across the membranes, they are called potassium channels. So the channel which I am working on or going to discuss is a potassium channel. Actually, it's a chimeric variant of a potassium channel, KCSA, derived from the soil bacterium Streptomyces lividans. In fact, KCSA was the first membrane protein whose crystal structure was available. It's a tetramer, meaning 4 identical units, with each monomer having 160 residues, and the size of the protein is 18 kilodalton, pretty big. My protein KCSA KB1.3 has 11 mutations on the turret part. So here what you see is a comparison of my protein with that of the wild type KCSA protein, and the ones highlighted in blue are the mutations. So we in our group did a lot of studies to understand the proton ligand interaction of this protein, dynamic studies of this protein, and of course many structural informations were derived using this solid state NMR spectroscopy. Now I will briefly introduce how the gating mechanism works for an ion channel, how it conducts the ions across the membrane. Typically, an ion channel shuttles from one state to another. As you can see over here, there are different states. In the resting state, one would find the channel in a closed conductive state, meaning it has got two gates, one on the extracellular part and this one on the intracellular part. This will be in closed state. Both the gates are closed, so no ions are going to pass through the cell membrane. Upon receiving the stimuli, pH, in our case we did almost all studies at pH 4 to open the gate. So upon receiving the stimuli, the intracellular gate opens and the ion starts to conduct. Upon depletion of the ions and in the continuous presence of the stimuli, the channel then enters into a state called open inactivated state, which upon changing the stimuli, the intracellular gate closes and moves to the closed inactivity state. With time, the extracellular gate also closes and comes back to the resting state. So I hope I gave a brief introduction of how ion channel works.